Hello. Hello, am I audible?
Yes, sir.
Okay, good morning, everyone. Welcome to the session. Okay, so this session is the last session for this week two, and probably the agenda of this session is to discuss. Yeah, so before we start the session, humble request to host, please start at time and stop at time. Sure, I'll try to do that. Yeah, so the thing is, sessions like live session and open session, that what happens is it is a two-way session, right? So where where students ask questions and we try to answer. So in that session, time management is not an issue. So it starts within the given time and ends within the given time. But when we talk about certain coding session, we need to, we have a target to complete. So yeah, so we'll try to set a target that completes in within 2 hours. So it sometimes it might get extended. So yeah, so thanks for pointing that out. We'll try to finish this session also within time. Okay. Yeah. So this session is mostly kept to. So I want this session to be again a two-way communication where you people keep on asking doubts and we'll try to clear. Okay. So this is more of open session. Why? What is the difference between open and the session that we have for a specific week? Is that you can ask questions from week one to, right? So you can ask questions from week two, all the questions from there, and also from week one. Okay, so yeah, so this is because you may not be able to go through all the videos, solve our questions within the given time of that particular week. So as it's like an extension of any doubts that you might have for the previous weeks, right? So yeah, please. I saw, like, while joining, I saw somebody's hand raised. Yeah, so that you can simply unmute and answer, like, question, ask your question. Yes, yes, Mehak.
So I have a doubt on practice question. Like it's the last one of week two.
Last one of week two. Okay, what is it about?
Number systems.
Okay, so is it the same that I took it on Wednesday, right?
I, I'm not sure.
Yeah, so were you present in the session?
Yeah.
Wednesday's session evening?
Yes, sir. But like I was really new to number system, but now I
Okay.
have grasped all the knowledge required for for this. But I want to know about Unicode. That kind of stuff. But I know number systems. I can convert from one system to another system. I just have a few doubts on that.
Okay, so what is your doubt exactly? You want to know about Unicode?
Yeah, like, and also how to go about solving these type of questions.
Yeah, so these questions are very specific. See, the question that came in the practice section, right? So that is a very specific question. You will not see very so many variations of that question. What can be the variation? Let me okay, share my screen. Let me join this tab and share my screen. So what happens is, see, the code, the number that you saw in that question was u plus something, and that was, there were 5 digits, right? So that five digit is, each digit of that is a hexadecimal representation of a code. Okay, so what will happen? There are 5. In certain cases, you will find not 5. You will find 4, 3, 2, like that. So that is specifically done to change your the encoding byte, right? So the question, the encoding number that we had in the question was using 4 bytes. What variation can we bring there? We can convert it into a number which will take only 3 bytes or 2 bytes, right? So that will be only the variation in those type of question. Basically, the idea of that question is, each question, so if you have gone through the slides, you may have seen that each Unicode point is a unique uh, point that represents a character. Okay, now how you represent it in different encoding techniques is what we are trying to see there. Okay, so the Unicode point, u plus whatever it is, 5, 4, a9, whatever it was, is a unique character, okay, specified in Unicode. Every character has a unique representation specified by Unicode. That is what you need to understand. And this Unicode can be represented in multiple encoding techniques like UTF-8, UTF-32, UTF-16, UCS2, things like that. Okay, so how each Unicode represented in different encoding techniques is what the table shows. Okay, the table in
Okay,
the
sir.
slides. Yeah.
Sorry to interrupt you, sir, but are you sharing your screen?
No, I'm not.
Okay, sir.
I'm not. I'll just share. So if just a minute. I wasn't sharing because I wasn't writing anything. Yeah. So if you see this, what I'm saying here is this is U plus, let's say it is a number 543A9. Okay, so this is the number. So this is actually a Unicode representation of a character. Okay, it is a Unicode representation of a character. That character can be anything that is there. So including English, including English and all the other languages. Okay, so each character in the language set is represented by a Unicode. Okay, now if I'm using UTF-8 encoding technique, okay, so this character has to be encoded in UTF-8. Okay, so let's say my system. So see, in the HTML document also that we saw in the last session, we said in the meta tag we represented that UTF-8 char set equals to UTF-8, right? So what does that say? That says that the characters that you will be writing in the HTML document will be encoded in UTF-8. Okay, so this UTF-8 encoding is something that we need to look at. Okay, now this is a character representation. Only that in that question we have been given with a table that says, okay, if you are having these many bytes, take this. If you're having these many bytes, take this. Now you may have observed that the bytes in that has things like, let's say it is an 8-byte thing. Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and you may have seen that some of the bytes, or some of the bits, not bytes, sorry, some of the bits of that particular byte were already filled. Okay, so it was like 1, 0, and then we saw crosses. Okay, so this 1 and 0 is the interpretation. Okay, this represents the interpretation of this particular byte, and this is the space where you store the actual data. Okay, so what is this interpretation and what is this actual data? All right, so this actual data comes from the character that you want to store. Okay, so the conversion of this this number, or conversion of this representation Unicode number into binary will be something that we have done. Okay, now we have a binary code, so that binary part is the actual data that we need to store. How to store it is this. Okay, so some part of that will come here, and that is why we have crosses here. What does cross mean? It means that it is don't care. Don't care as in you don't have to worry about what is coming there as 0 or 1. It depends on the data. Whatever the data is, that will come in. Okay, so if I have a binary data, so it is 6-bit. So if I'm writing here is like 1 1 1 0 0 0. So this is my data that will fit in. It can be anything, 1 0 1 0 1 0. Okay, so this also is a data. So I am representing that. So I'm not saying that, okay, put it as 1, put it as 0. I'm saying that put it as X. Anything can be the data. Now what does this mean, right? This interpretation. So while like watching the lectures, you may have seen that, okay, there is the information, the actual information that you wanted to store, plus the interpretation of that information, right? So when we talked about character A, right, character A, so it was like having 65. Then there was some binary, I don't know exactly what it was, but some binary part, and then something else. So when you talk about this, let's say this 11010. Now I'm not sure if this is the actual representation or ASCII representation of A. I'm saying consider this is the ASCII representation of capital letter A. Okay, so what I'm saying is, if I give you this number 11010, okay, since I have been working on this, I would say, okay, it is an ASCII representation or binary representation of character A. Somebody would say this, no, this is simply a binary number whose decimal representation is this, right? Somebody would say, okay, no, it is just bits, randomly said bits, 11010. Okay, so these are all the different interpretations one might take out from looking at this number 11010. Okay, now the same thing will be done by computer, right? The computer will have the data, but we also have to specify that this is the data for this. This is the data that represents this, right? So for that representation, we have some pre-written bytes. Okay, so this pre-written bytes gives the information about the data, what the data means. How do you have to take the data, right? That is the reason this is fixed, right? We cannot make the changes on this, because if we make the changes on this, the interpretation will change and the actual data, the information that you wanted to transfer, will not be transferred. Not be transferred as in wrongly transferred, because it will be interpreted by something else from the compiler of the other machine, right? So therefore we are having some bits as fixed and some are variables where we put the data, right? This part is clear.
Yes, sir.
So that is what it is, right? So in the question we gave the table, but now as a human, as a user of this data, I don't have to bother about what is the information, because what is the interpretation, because that is for computer, right? Computer to understand. And then and for that very reason, I don't need to remember also. That is the reason we gave you table. Okay, just need to find out how many bytes your actual information is, and then you set it along accordingly. Select how many bytes your information is taking, and you set it accordingly. So that is what the question was, like this. So there were around four bytes, right? 4 bytes. Now every byte had certain representation, how you represent. So that was what, that is it. Anything else you want to know about this?
Yes, so like how to solve this.
Hello.
Yes, sir. Like how to solve it. Can you please?
Okay. Okay, so you're saying that how to solve that question. Just a minute. Yeah, but see, as a reference, you can watch that live session, right? It is there in the YouTube also. The thing is, see, I'll give you just a small explanation of that. See, what is happening? There is a number. Okay, just let's say this is the number 543A9. It is similar to what it is. It actually, I don't know. Okay, so what you need to do is, this is a five. This is a five, right? Five digits you are seeing. So these are 4 bits hexadecimal numbers. Okay, so these are hexadecimal numbers. So what you need to do is convert this. So you don't. This is just a representation, right? So see, this is what I was meaning there. This U plus is for understanding that, okay, the data that is followed by U plus is the actual Unicode. Okay, this is the representation. This is not the actual data. This is only the interpretation of what you interpret this 5 digits as. Okay, what Unicode says, whatever comes after me are the 4-bit hexadecimal numbers. Okay, so you convert this 5 into hexadecimal number, 4 into hexadecimal number, 3 into hexadecimal number, 8 into hexadecimal number, and 9 into hexadecimal number. How many bits will you have total? Hello.
20, 2020.
Yeah, 20. How did so yeah, Mehak, did you get the answer why we are saying 20?
Because each letter it has 5.
Yeah. Hello.
But it should be 25, I think.
No, it's a 4-bit, not 5-bit. Each digit is a 5-bit hexadecimal representation. 4-bit, right?
Okay, right. Then yeah, it's
Yeah,
20.
so that became a bit 20. So you'll write 4-bit. Okay, what is the 4-bit representation of 5 binary? Hello.
Yes, so like calculating.
Okay. Okay, so see, from 1 to 10, from 1 to 10,
It's
you
0,
need
1, 0, 0,
1, not 1 to 10 also, 1 to 14 or 1 to 15. 1 to 15. This is you should know the exact direct conversion.
Like I calculated it. It's like 0, 1, 0, 0, 1.
0 1 0 1 0 0 1 0 1 0 0 1 is directly 5 bits, right?
Yeah, like 0, 1, 0, 0, 1.
Yeah, but then I said it's 4, it should be 4 bits.
So I just, okay, then it should be 1, 0, 0, 1.
So 1 0 0 1. It is the representation of 5. Okay, how did you come up with this?
I just did long division with 2.
Okay, let's do the wrong division with 2. Okay, so if you divide by 2, what remains? 2. What stays? 1. If you divide by 2, what remains? 0. Sorry, what remains when you divide by 2? 1. What stays? 0. If you divide by 2, what remains? Nothing remains, but what stays? 1. So you take this, it's 1 0 1, not 1 0 0 1.
No, we'll also take the last one. So should be 0, 1, 0, 1. So
Yeah, so 0 that we can add later on. That's what I've added to
but
make it 4-bit.
so I have one question. If we were doing it by 8 instead of 2, then we would not have taken that last 0, right? Like
Which last 0?
the one you added in the beginning. So
Hmm.
we wouldn't have taken that 0 in octet conversion, right?
Yeah, we would not have taken that.
So we just only do that for binary, not for any other conversions.
We do that for only hexadecimal, not binary.
It's we're converting to.
Yeah, it's what we are Yeah, so it's it's what we are converting from.
So if we convert hexadecimal to octet, then we take the last thing, 0.
No, so when you want to convert hexadecimal to octal system, what you'll do is you'll go to binary and then octal, or you can go to decimal and then octal. But this is again hectic, but this is better. Binary, from hex you go to binary and then you go to octal.
Okay, sir.
All right. So if you yeah, so yeah, so this is one way. This is another way. You can go from hex to decimal and then go to octal. But the thing is, see, this is the decimal, right? This 5.
Yes, sir.
Decimal as in I'm taking it as a single number, integer number, and then I kept on dividing it. Okay, so similarly, what we'll do, we'll convert this hex to decimal and then keep on dividing by 8. That's what we'll get. Yeah, but don't worry about this method because this is very long method. This is way better and very easy. Okay, you need to convert this hex into binary and then you convert it into octal. How do you convert a binary into octal?
I think no.
Grouping of 3 bits.
Yeah, see, so let's say if I'm having a number 1 1 0 0 1 1 0 1 0 1 1 0 1 0. All right, so what you need to do is you need to go from here, from the left side, right? We'll start with least significant bit. From the left side we'll start and make a group of 3. Okay, so here I'm remaining with 1, so I'll add 0. Okay, why we cannot do from here? Because if I do that from here, I will be doing with this, right? Okay, and here if I add 1 0, my number changes. Right, so number 0 cannot be added on the right side, but can be added on the left side. So therefore, this is the wrong technique. This is the correct way. So this is the octal representation of the binary number that I was creating here, right? So this 0 wasn't there. Okay, so if I want to convert this will be 3 1 5 3 5. Okay, base 8. right? 3 1 5 3 1 5. This is how you convert into a binary into octal number. How do you convert a binary into hexadecimal? I'm
Sorry,
taking,
I didn't
sorry,
understand that.
sorry, this pen is just a minute.
So I didn't understand that part. How did you convert to octal like 31535?
Which one?
After like grouping, like how did you come up with 31535 here?
So after grouping, see, I had number 0 1 1. Okay, 0 0 1 1 0 1 0 1 1 and 1 0 1, right? So these are all these are all the binary representation of numbers in octal system, right? So 0 1 1 is what? 3. 0 0 1 is what? 1. 1 0 1 is what? 5. This is again 3 and this is again 5.
And if there's number which is not making 3 group, then we just add 0 on the left side, right?
Yeah. If you want to convert it into an octal number, then you add 1 0. So if you come up with, let's say, one number 1, and you want to, only one number is there on the left side. Let's say I'm having this number, okay, 1 0 0 1 1. Now I want to convert this into hexadecimal. What I'll do, I'll make a group of 4. Okay, so this is one group and this is the another group. So how many numbers numbers are deficit? That is 3. So I'll add 3 zeros. So it depends on that. You need to fill the spaces just to make it 4. In octal system, you need to fill the spaces just to make it 3.
Okay, so
Right? So this is 1. And what this is what? 3 again.
Sir, I had a doubt.
Yeah.
In order to convert from binary into decimal or hexadecimal, it would require 4 bits to be grouped together, right?
Yes.
Sorry for the noises on the background.
No. So the binary but from binary to hex, you need 4. Okay. From binary to decimal, go to the power number system, right? So this is not the way of, you cannot group into something for decimal.
Okay.
Right? For hex, you can group into 4. For octal, you can group into 3. But for decimal, you don't need to, you cannot group into something. There is another way.
Wait, so how will we exactly convert from binary to a decimal number exactly?
Okay, I'll tell you that. Okay, so just a minute, let me make some space. Okay. Yeah, so see, every binary number, let's say I'll write a, okay, let me go to the pen. Yeah, so every binary number, that is, let's say 1 0 0 1 1, and let's say again 0. So every binary digit is actually having a place value and space value. A place value, okay, and base value, not space. Place value and base value. Let me write this. It's place value and base value. Okay, so this is a binary number, right? So my base value is 2. All right, this is 2. Since it is a binary number, my base value is 2. Okay, and the place value is actually, I'll count it from here: 0 1 2 3 4 5, right? So it's place value. For each one, we have to find out place value. So the place value for this 0 is 0. The place value for this 1 is 1. The place value for this 1 is 2. The place value for this 3 is, this 0 is 3, and so on. Okay. Why is this important? Because this will allow me to convert this number into decimal. Okay. What does this say is that whenever, so what I'll do is I want to convert it into decimal, right? So what I'll do is I'll make 5 places, because this is how many? 6-digit number. So I'll make 6 places. Okay, and after every place I'll write into 2 again. I need some space. Okay, just a minute. Sorry. So are you clear up to this part, this place value, base value?
Oh yes, that I am.
Okay.
I actually got to understand it in the middle itself, that if we have to convert to hex, then we'll have to group into group 4 bits together in order to get one hexadecimal bit. And in order to convert to decimal, we'll have to multiply it with 2 to the power x, and the x is respective of the place itself.
Yes.
The digits that you wrote from 0, 1, 2, 3, 4, 5. So that is actually going to be the power of 2, and that will multiply with the bit that is given in the place below. So
okay,
100, 110, yeah.
Yeah, got it. Yeah. So okay, so before I go with this, I'll again tell you one more way of saying that how many numbers you have to group in while going to an octal system. Okay, so this is just a minute, this text. Okay, sorry, drop. So this is binary 2. Okay, I want to go to octal. All right, and then again I'll write binary 2, and I want to go to hexadecimal. All right, so for 2 to become 8, what is the power I need to raise with?
3,
right? And for 2 to become 16, what is the power I need to raise?
4.
That is why we are grouping with 4 when we are doing with hexadecimal, and that is why we are grouping with 3 when we are doing octal. Okay, now if I want to go from binary to decimal, what is the power I need to raise?
I believe it's going to come before 4, but after 3.
Yes, it is
That is the
something between 4 and 3, right? So you're not having us exact number, right? It is something. That is why you cannot group for decimal.
Okay.
Got it. So this is the reason why we cannot group. But then how to convert a binary number into decimal? That is what I'll show you.
Okay.
So we'll go to the exact meaning of what a decimal number is representing. Okay. When I write 1 and 0 and 0 and 1, what does it actually mean? Okay, so this is the same number I'm taking here. What I'll do is I'll write 0, okay, 0 into 2 to the power, that is the base value, raised to the place value. What is the place value of 0? This is 0. Okay, plus. So this is this, whatever I wrote here is for this digit. Now we'll go for 1. So this 1 is there, no? That's why I'm writing 1. And then I'll multiply it with 2 to the power, the base value raised to the place value. Then I'll add this. Then I'll go to the other one. Since it is 1, I'll write 1 into 2 to the power, base value powered by raise value, base value. Okay. Then again, I have 0 now. So this is 0 into 2 to the power 3, right? Base value, the power with place value. Again, I'll go with 0 into 2 to the power 4, that is added here, right? And then finally, I'll go with 1 into 2 to the power 5. Okay. Now I simply need to add this. So 2 to the power 5 is 32 plus 0, because 16 is multiplied by 0, plus 8 is multiplied by 0, plus 4 is multiplied by 1, plus 2 is multiplied by 1, and then again it is 0. How much it is? 32, 4, 6, right? So it is 38. So this is the decimal representation of whatever I wrote here. Is this clear?
This is clear, but how will we represent really large numbers? Do we have to divide them all the time?
Divide them as in?
As in, if there's a really big number that is going into trillions or quadrillions, then do we have to divide them by 2 all the time in order to get the binary number, or is it divided into sections and then those are converted to binary system?
No. You have to divide it by 2. Sections won't help you. See, why is that happening? Because, see, let's say if I'm having a number that is 8-digit binary. Okay, so 1001 0110, right? This is an 8-digit binary. So if I do this, I'll have to go from 0 to 7, right? So I'll keep on raising my power whenever there is 1, and whenever there is 0, I'll keep on raising my power and multiplying it with 2 to the power 7, 2 to the power 6, 2 to the power 8, not 8, 5 and on, right? But if I group this, let's say I'm grouping it this way. What is the maximum value? It is going to the power 3. What is the maximum this value is going to the power 3? You add up, you will never get the answer.
Okay, understood. Yeah.
Right. So if it is really big number, you have to keep on dividing it unless you come to the actual value. So that is the way. Like, so if this is 5 here, if I'm having 5, 8, 5, 0, 5, 2, if I keep and I want to convert it into binary, I'll have to keep on dividing it unless you get either 1 or 0 in the remainder.
Okay, understood. Yeah.
Okay. And then, yeah, so that's why this way is different for decimal and then for others, right? For 8 and hexadecimal, it is pretty simple converting them into octal and hexa, but for decimal, it is a bit different. Okay, now if I want to convert this decimal number into octal, and always remember, this number is taken as interpreted as decimal. Whenever you are dividing with, you want to convert from any number to any number, interpret this as decimal. Then only you can do this. Okay, so if I want to convert this 38 into octal, what I'll do is I'll keep on dividing this 38 with 8. Okay, so if I divide this 38, so 8 4s are 32, it 5s are 40. All right, so what will come up here? 8 4s are 32, right? So what we write here? 4. I'll write here 4. And what is the remainder? I guess 6, right? Then again, I'll divide this 4. Okay, I'll write what I'll get here? 8 4s are, so 8 zeros are, sorry, 8 1s are, sorry, 8 zeros are 4, and what is the remainder? 4. Okay, so and then I need to collect this like this. So it is 46 base 8. So the 38 base 10 is 46 base 8.
Okay.
Right. So this is how you do it. So the number, this 10110, is getting 46 base 8 when you convert it into decimal. So it is better, no? So directly go from binary and group it. All right. So if I need to verify this, how will I verify this? I know this number, right? Binary. I'll group it into 3. So this 100 is 4 and 110 is 6. This is 46 base 8.
Okay.
Yeah, got it. So this is how we need to do conversion. So when we go, it's pretty simple if you want to go from hex to octal. It is simple when you want to go from hex to decimal, but this division is required when you go from decimal to any other number system. Yeah, so there is some conversation going on in the chat. Let me go through that. Okay, is there something like trinary system 2 with base 3? Yes, we can make. We don't use it, we can make. Digital system works on high voltage and low voltage. Yeah, that is the physical meaning why we are having 0 and 1, because either we do it, either we don't do it, right? Anything happens, either everything doesn't happen. So that is, we make everything convert into yes or no. The possibility is yes or no, right? Head or tail, 50% probability. But the thing is, you can make a trinary system. How to make a trinary system? Base 3, right? Base 3. So you will have digits like 0, 1, and 2. This is your trinary system. Okay. Same rules apply for trinary system for as they are applied in other systems also. Okay. So if I'm writing numbers in trinary system, first number will be 0, 0. Next number will be 0, 1. Okay. And then if I want to go to other numbers, so third number will be 0, 2. So in the last session, when I explained, I said that now that you are done with the limit, you'll have to change this, right? You have to change this. So this becomes again 0, and this becomes the next number. So that 1 0 in base 3 is actually 0, 1, 2, and 3 in decimal. Sorry. So 1 0 in base 3 is actually 3 in decimal. Similarly, 1 0 in base 8 is actually 8 in decimal. And 1 0 in base 16 is actually 16 in decimal. And what is 1 0 in base 10? It is 10. So there is no special rule, same thing comes, right? Because the last digit that we had was 0, 9. Now if I want to go, what comes after 9? 0. What comes after 0? 1. So this is 10. So the 10 in decimal is 10. You can make any system you want. It should have a physical significance, right? Why we are making it at the first place. I think this part is clear right now.
So like I have calculated like the 543A9. I've calculated its binary version, but some of them are like three bits long, and some of them are like 6 bits long and 5 bits long. So like how do?
Okay, right.
Screen, sir.
Yeah.
So can you explain once again that point? Why 10 in ternary system is 3 and 10 in hexadecimal system is 16?
Okay, fine. Just a minute. Let me clear some space. Okay. Is there anything important that you find on the screen? Take a screenshot, then I'll delete. So whatever I've written is not serial wise in sequence, but I guess if it helps you, you can take the screenshot, then I'll delete it. Okay, so see, so when we're talking about, let's say we'll talk about decimal, binary, not binary, hex, and then the ternary system, right? So in decimal system, how many letters do we have? Zero, not the letters. How many digits do we have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? There is nothing like 10 here. So this is a number system. This is the all possible numbers that you can put or use in a decimal number. Okay. Similarly, so hex will go from 0 to 15. Right? This is explainable, right? Self-explanatory. In ternary will go from 0, 1, and 2. Remember, whatever is the system, you cannot take that number in the number system. So you cannot take 3. You cannot take 16. And you cannot take 10. Why is this? Because the total number, so this 10 does not represent 10 as the final number. This represents total number that are there. Right? And since 0 is coming, the total number already become 10 when you reach 9. Right? So this is the total number 10. So that this 10 is what this thing means here, number system, base. Okay, so if we go from 0 to 15, there are total 16 numbers. That's why we don't take 16, because taking 16 will make it actually a 17 number, a 17 base number. Are you getting? So this 16 is what comes here. Similarly, I cannot take 3. I'll go till one number down, because the total count is actually 3, 0, 1, and 2. Okay, and this is the total possibility that I have for ternary number, and this is 0 to 9 is the total possibility that I have for decimal number. I cannot take any number like 1, 1. Right now, any number, as in, you can say, one can argue, okay, this is 1 and 1, you can take this. No, as one digit. You cannot take this number as one digit. Okay, if I'm writing 1 and 1, these are 2 digits. Right? So what we are focusing on, what is the character that you can present on 1 bit. Okay, so here if I if I want to calculate, if I count on things, right now there are number of things that I want to count, and then I keep on using, let's say I'll use decimal system for counting that. Okay, so I'll count like, okay, there is one number 0, then there is 1, then there is 2, then there is 3, 4, 5, 6, 7, 8, and 9. But will the counting stop here? Will the numbers of things that I want to count stop here? No. Can I take additional number in one digit? No, right? So I need to, and these are all 1 bit, right? These are all 1 bit. Can I add something greater than 9, which is having only 1 bit? No, I cannot do that. If I'm so this is actually the limit. that I can limit of things or entities that I can count with only one bit using decimal number system. Okay, so if I want to count things that are more than 9, say more than 9, not 10. Why? Because 0 is not a count. It is just a representation of number. Okay, it has a significance in storing in data, not in counting. So if I want to count something more than 9, I will have to increase my bit, right? Now, when a bit increases, so in one digit, this was the MSB, this was the LSB, right? What is MSB? Most significant bit. What is LSB? Least significant bit. Okay. So if I want to go above the limit of one bit, I need to increase the number of bits. So I'll increase the number of bit by 1. Okay. Now if I come here, if I cross this line, this 9 has to go to 0. Okay, it has to reload. These digits have to reload. Okay, and then this can start from 1. Why didn't it start for 0? Because it was already there. Doesn't make difference. Okay, writing directly 0 and till 9 or writing 0 0 0 1 0 2 will not make any difference. Okay, so but this is better in explaining, right? So if I want to add a new digit and I reach the limit, this 9 will get reloaded to 0, and next digit or next bit in the number system will take place after 0, right? Next bit. So similarly, we'll move ahead, and there will be a time where I'll reach 1 and then 9, 1 and then 9, right? Again, I'm reaching the limit. So what will happen here? Here, this 9 will get reloaded to 0, and this 1 will take the next bit, that is 0. Okay, this will keep on going. Once I'll reach a number that is the limit for both the bits, right? Bit will not change bits will not increase unless you reach the limit of that bit, right? So you're reaching the limit of this, but you're not reaching the limit of this. That's why we don't add any bit here. But here, if I have a number called 99, so I'm reaching the limit for both the bits. Both the bits together cannot handle any number greater than this number, 99. For that, I need to add a bit here. So if I add a bit here, every time now these both will reload. 9 to 0, 9 to 0. And what was the number here? Imaginary, that is 0. So this 0 will become 1. So this is how numbers go on, right? This is how numbers go on. So since this is for decimal, this phenomena will be followed for all the number systems that are there, right? So if I want to go with ternary, so this 10 in decimal is actually 10 because we have been following only decimal system. The number that we comprehend is the decimal number system. Okay, but now if I go to ternary, that is 0, 1 and 2, I'll keep on counting, right? So I'll go 0, 1, 2. This is the limit, right? And only 3 numbers. This is the limit. So if this is the limit, with whatever I can do with only one bit, I will have to reload this. So once this 2 gets reloaded to 0, okay, and then this new bit will be taken by the next bit in the number system, that is 1. Okay, but serially, if I try to count with decimal, this will be 1 0 1 2 and 3, right? So this 1 0 in ternary system is actually 3 in decimal, right? This is what I said. You getting?
Yes, please.
Okay, so what will happen in hexadecimal? What I'll do, I'll keep on going 0 0 1 1 1 2 3 4 5 6, and finally I'll reach F. Okay, so this 15 is not actually 15, it is F. Okay, I'll reach F. So for this, I'll just show you what are the representations. So we'll go till 9. Okay, and then 10 becomes A, B, C, D, E, and F. So this A is 10, 11, 12, 13, 14, and 15. So this 15 is a F. When I want to write, I'll represent it as F. Okay. So this F this f I'll reach. So this is the limit for hexadecimal system. This is the limit. And what is the decimal count here? 15, because 0, 1, 2, 3, 4, 5 all the way till 15. Now if I want to cross this limit, I'll have to add an extra bit. So for adding an extra bit here, this has to reload, right? So for f, then it will go back to 0. This will become 0 and this will become 1, right? So this 10 base 16 is actually 16 in decimal. I think this is clear now, right? Hello?
Yes, yes, sir.
All right. So this is how. So the 10 has different interpretation, not only 10, other numbers, right? So 11 in 16 base, what it will that be? It will be 17 in decimal, right? So that is what. Every other number will have different representation unless you write the base. But in the day-to-day life, we don't write base, right? So it will be very weird to write 1052 rupees and base 10, right? You don't write this base because we understand decimal. So we don't write specify that it is a decimal number. So that is how it is.
So how do we change, how do we convert a float value into binary?
Yeah, so we convert a float. See, the thing is, if you want to convert a float value to binary, you have a you want to convert a float value to binary. This means you are having a number, let's say 25.52. Okay, so this is a decimal number. Sorry, my pen doesn't go there. So this is a decimal number. Okay, and you want to convert into binary. How will you convert this 25 into binary? This will be 5. So place value, right? Again, place value. So this is 0, 1. So it will be 5 into 2 to the power 0 plus 2 into 2 to the power 1 plus, right? So this is easy, right? So 2 to the power 1, that is 2 into 2 is 4 and 5 ones are 5. So 5 plus 4, 9. What I'm doing? No, don't get confused. I did something wrong here. Just a minute. Just a minute. So just draw. So we want to make this 25.52 into a decimal number. So what we need to do is, so this 25 will take it differently. So this 25 will be converted into binary, right? So this 25 will be converted into binary. How do we convert it into binary? We'll write it as 16 plus 8 is 24 and plus 1 is 25. Okay, 16 plus 8 plus 21 is 25. Okay, this 16 is 1 0 0 0 0. This is binary representation of 16. This is 8 and this is 1. This is the 1 0 0 1 1. So the 25 has binary representation of 1 1 0 0 1. Okay, similarly, if I want to, so how did I do this? I took it as a multiple of 2. Power of two things, right? 16 8 1. What is 1? How do we come to 1? That is 2 to the power 0. Okay, now I want to make similarly 52. 52 similarly I'll have to make with 2 to the power with the powers of 2. So it is actually 0.52. Okay, 0.52. How will I come up with this number using 2 to the powers of 2? So we need to solve something. We need to solve this. How do we do this? This will be this 2 to the power. What will be 2 to the power 1 by 2? So we have gone in the integers like 0 1 2 3 4, but here we'll go with the negative terms, -2 -3. So this represents that all the numbers here are after the decimal point, and they will come up as like that. Okay, so let me show you it in different way as in different place. Okay. So whatever comes here, so I reach 2 to the power 0. Next number that if I want to go here, it will be 2 to the power minus 1. Then it will be 2 to the power minus 2. 2 to the power minus 3. What are these doing actually? 2 to the power minus 1 is actually 1 by 2. 2 to the power minus 2 is actually 1 by 2 to the power 2. And 2 to the power minus 3 is actually 1 by 2 to the power 3. Okay, so 1 by 2 is 0.5. 1 by 4 is 0.25. 1 by 2 to the power 3 is 0.125. Okay, so let's say what was the number? It was 25.52. Okay, 25.52. So we need to make this number, right? So it is 0.5 plus 0.02. Okay, so 0.5 is done, right? 0.25 we cannot take. Why we cannot take? Because if I add 0.25 here, the number will become 0.75. This is not what we want. 0.5 we can take. 0.25 we cannot take. So we'll reduce. We will have to cross it. Okay, 0.125 we cannot take. We'll have to cross it. So if I keep on dividing by 2, what will I get? 0.06265. Can I take this? So if I add with 0.5, it will be 0.56. So we cannot take this. So we need to go further to the power. So this was 1 to 5, right? So this will be 4, 0. So if I take 5, it will be 1 upon 2 to the power 5. So 1 upon 32 is how much? Let me calculate that. 0.03125. I'll keep on writing it unless I get till I get the number 0.03125. Okay, will that do? No, because it will become then 5.3. So I have to go forward. So this time I'll take 64. So it will be 64, 1 by 64. Not 64, 2 to the power 32. Yeah, 64. It will be 0.15625. Okay, so it will be 0.15625. Can I take this number? Is it less than 5 to? Yes. So we can take this number. At what place it is coming? 2 to the power 6, right? So it will be 11001.1. So this was 2 to the power minus 1, right? So this is minus 1, 2, 3, 4, 5, 6. So I can take 0, 0, 0, 0, 1. Is it? No, because wherever I reach 25.51565. I need to add some more numbers, right? So this is how you do it. So maybe I'll get it somewhere here like this. So this is how you convert a decimal number into binary. So binary decimal number, floating point decimal number will also have floating point binary number. So am I clear? See, the calculation is getting longer, right? So if I take a number, let's say 25.75, what will be the representation? 11001. Okay, 0.11. Why? Because this 1 will represent, it is 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. So this will become 0.5 plus 0.25. So it was, or entirely it will become 0.75, which is this. Okay, so the decimal representation, decimal point, binary representation, decimal point. This is clear?
Yes, sir. Yes,
Yeah,
sir.
but I think we don't have to go to this many detail. This is just okay. You asked it. It is okay. Okay, so only we wanted, okay, some binary system is used to represent information, encodings, and this and that. Okay. Yeah, so somebody is asking base is 3, so we are putting 3 to the power 1, which is 3. 3 to the power 1, which is 3. I didn't get this, Nitish. What are you meaning by this? Okay, before we talk on this, is this clear? Decimal point?
Yes,
So
sir.
whoever asked me this thing, like
Yes, sir,
how do
I
you
did.
can? Okay, so is this clear, right? So this is how you do.
Yes.
I
How
took
about-
a very wrong number, 52.52, 25.52. 52 will take a lot of, point and zeros and ones and zeros.
Sir,
Yeah.
I have a doubt.
Hmm.
The number of digits which come after the decimal point in a base 10 number system, it doesn't matter for binary. The length of the number of digits which come after the dot could be longer or shorter depending on how my calculation is going with the 2 to the power -1, -2, -3.
Yes.
The length could differ, right? Or would it, the
No,
number
no,
of digits?
no. No, it doesn't have to do anything with digits. See, why? Because see, if you see this 1, 0, and you put 100 ones and zeros after this, it will definitely be smaller than 1, 1.
Right.
Right. So if this 1, 1, so how long can you go before you reach 1, 1? How long can you go here? If you fix this 1, 0, how long can you go here?
Infinitely many times.
Infinitely, right? So this a number can be lesser than what we want to convert, but still can have so many ones and zeros after decimal.
Got it, sir. Got it.
Right. Here, if you observe this, we were going longer, doesn't matter, but we were having 0 here, right?
Right.
So this says that it is definitely smaller than this 1 and 1.
Got it, sir.
Yeah. Okay, so who asked me about that? Base is 3, so we're putting 3 to the power 1, which is 3. Okay, so we're talking about the conversion of 10 in ternary system. Conversion of 10 in ternary system. Okay, got it. Yeah. That is also, so that's what I said. Once you make the number system, all the rules of conversion will apply. So what you're meaning is, how do you convert this 3 to 3 of decimal to ternary, right? So how will you do this? So actually converting from here to here is what you want, right? So if it is 1, 0 to the base 3, how will it mean 3? It will be 3 into 1 to the power. What did you mean? Yeah, so it is conversion of ternary into decimal is what you're saying, right? So yeah, so that is what we do, right? So it will be 1 into 3 to the power 1 plus 0 into 3 to the power 0. So this 3 to the power 1 becomes 3 and this 0 becomes 0. So this is 3. So 1, 0 base 3 is 3 in decimal. Same method I used. Why? Because I've defined a number system following same rules. So it will follow the same rules. No issues with that. Yeah, anything else? Is this clear, whatever I've said till now?
Yes, sir.
Okay, any doubt on this? So yeah, so this is like quite a detail on binary system or number system. Will not go into much into that. Okay, simple conversions here and there would suffice. Just need to know, okay, what does what it means. Sorry. Okay, shall we move on with the next? Anything else about that?
So that
So nobody's asking about HTML and CSS.
So that you did question, like
Which one?
this that UTF question, UTF 8 question, I have calculated its binary, like what to do next.
Okay.
It was U plus 54389.
It is U plus
5
5.
3 A 9. So
Okay.
the one I calculated is, so the first one is 0101.
That's 0101.
And then it is 0010.
0010.
And then it is 110.
110. Three
Yeah.
digit. Why?
I'm getting 3 digits for 3.
So 110.
Yeah.
Okay, let's make it 4.
So we can add 0 here. And then I have 0, 1, 0, 0. Okay, 5 zeros and then 1. 0, 1, 5 zeros, 1.
0, 1, 5 zeros. 5 zeros and then 1. Okay. And then?
And then 0, 1, 0, 0, 1.
0, 1, 0, 0, 1.
Yeah.
Okay. So why are you adding this 0? Since this 1001 was already 4 digit?
This is the answer like which came like this represents time.
Okay. Let's see how it came. Okay. So if you're saying this is the, so what I said, you have to consider each number as decimal and then convert, right?
Yes, sir.
Although they are hexadecimal, you need to consider each number as decimal because representation will be same. Okay, so this 4 means 0010, right? So if I convert this 0010 into decimal, I should get 4. Right?
Yes, sir.
If I convert this 0110, I should get 3. If I convert this 01000001, I should get A. So what is A actually? A is 10. Okay, let's see. So if I want to convert it 0010, it will be 2 into 10 raised to power 3 plus, sorry, not this. It will be 0 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. What am I getting here? 2, right? Similarly, if I do this 0110, it will be 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. What am I getting here? 6. Okay, we will not solve this. Okay. So if I want to solve this, convert it into decimal, it will be 0, 1, 2, 3, 4, 5, 6, right? So I'll take only this and last one. So it will be 2 into, 1 into 2 to the power 6 plus 1 into 2 to the power 0, which looks like 65. 2 to the power 6 is 64.
So we don't have to take 10 as A.
Sorry?
So we don't have to take A as 10 here, right? We have to take it as 65 only.
No. This is hexadecimal, right?
Yes, sir.
And this A in hexadecimal is 10.
So it's wrong. So
So this is a hexadecimal 5, like a 4-bit hexadecimal number, right? This is not an ASCII encoding. That's what. Therefore, see, you're not wrong because A means 65 in ASCII. A means 10 in hexadecimal. So that's what. Interpretation is also there along with the information is very important. Right? That is what the slides say. Okay, so simply you need to convert, right? Need to convert this into decimal. So see, this 5 is.
So I've converted 10 to 0, 1, 0, 0, 1, 0. So instead of this, in the 4,
0, how much?
0, 1, 0, 0, 1, 0.
0010. Shall we convert it into decimal? Shall we try to make it into decimal and should get 10?
Yes.
Okay. So if I write 0, 1, 2, 3, 4, 5, it should be 2 raised to power 4 plus 2 raised to power 2. 1. How much it is? 18, right? You're not getting 10. See, anything there must be a problem with conversion into decimal. Okay, so conversion of a decimal number into binary. Let's do that first. Let's remove the confusion there, and then you will know that why is this coming as wrong, why is this coming as wrong, why is this coming as wrong, right? That is the reason I have not written these numbers here. Okay. Okay, so what is the number? Let's say it's 4. Oh, sorry, it's 4. Okay, what I need to do is I need to divide it by 2. So if I divide 4 by 2, how many times should I take? 2. What is the remainder? 0. If I divide 2 with 2, if I divide 2 with 2, how many times should do I have to take? 1 times. What is the remainder? 0. So if you reach the remainder 0 here, you're done. So 1 0. Is it?
Shouldn't
No.
it be 0 0?
No, because you stopped here, right? So if you come here with 0, you have to take it 1. So if you want to reach 0, 2 raised to power 0, how many times you have to take? 0 times, right? So this is not 0, this is 1 actually, right? So 2 1s are 2, 2 1s are 2. How many times we are taking, that is what we are writing here, and what is the remainder is what we are writing here. Okay, right? So if, let me write it again, this is 4, this is 2. How many times we have to take to get 4? We have to take 2 times. So if I take 2 times to get 4, what is the remainder? 0. How many times do I have to take 2 to get 2? 1 times. In that case, what will be the remainder? How many times do I have to take? 1 times. What is the remainder? 0. Okay. Again, if I take 1, how many times do I have to take to get 1? 0 times, because I cannot get 1 by taking any integral multiple of 2, right? So I need to take here 0. What is the remainder? 1. Okay, so you need to reach 0 here. You need to reach 0 here, and then you need to collect these numbers. Okay, so what I come up with? 1 0 0. Want to make it 4 digit? I'll do it 0. So this is the representation of 4. Right. So you may be doing this, but there must be some confusion here.
No, sir, I just wrote it the opposite way.
Okay. So again, we'll go with 3. So this is 3. So you want to divide 3 by 2. How many times do you have to take to reach 3? You cannot take 2 times because you reach 4. So you take only 1 time. 2 1s are 2. Okay. What is the remainder? 1. Okay. How many times to get, how many times you have to take multiply 2 to get 1s? 0 times. What is the remainder? 1. Okay. So once you get 0, leave that line and collect from here. So it is 1 1. To make it 4 digit, 0 0 1. This is the representation of 3. So this is 0 1 0 0 0 0 1 1. Okay. Now the toughest part, A. Okay. So A is actually 10. So I'll do it here. So if I take 10 here and write 2 here, to get to 10, how many times 2 should be multiplied? 5 times, right? What will be the remainder here? 0. To get to 5, how many times should 2 be multiplied? 2 times, because 3 times it will be 6. So I need to multiply it 2 times. What will be the remainder? 1. To get to 2, how many times do I have to multiply with 2? 1 times. What will be the remainder? 0. Now, since I have 1, how many times do I have to multiply 2 to get 1? 0 times. And what will be the remainder? 1. So once you reach 0, box it, cut it from here, and select these numbers in this order. Why am I giving arrow? Because you have to select from this. Okay, so this is 1 0 1 0, right? It is 1 0 1 0. This is A, or 10. Okay, so I'll write this here, 1 0 1 0, and for 9 it is 1 0 0 1. Note that every even number is having 0 at last. Every odd number is having 1 at last, and 0 for every even number. right? So this is the correct binary representation of this hexadecimal number. Is this clear, this conversion?
Yes, sir.
Yeah. So now, once your conversion is done, how many digits do we have? 20. Okay, so we have 20 digits, and in the chart that has been given to us, it has like 7 free bits, like 1 byte, 7 free bits, 2 bytes, I don't know, 11, 3 bytes, I guess 16, and 4 bytes, 21. Right? So 21, see, our number is 20 bits long, so it cannot come here. It cannot be stored within 7 bits, right? It cannot be stored within 11 bits, cannot be stored within 16, can be stored with 21. Okay, just we need to bring that one extra bit just for storage. That should not affect our data. For that, we need to add 0 here or here on the LSB or in the MSB.
Yes, sir.
Yeah, no, what I'm saying is, where do we need to add the 0? Here or here, so that my data doesn't change.
Oh, right. You applied it on.
Here,
No, sir.
so it should be added here, right? Why not here? See,
Sir,
because
value is changed.
yeah, that's what. So if I add 0 here, my entire number gets shifted or to the left. Shifting of number to the left is changing or playing around with MSB. Changing MSB will change your data. Right? See, if you have 20 rupees, okay, what will happen if you add 0, and what will happen if you add 0 here? Where is, in which case data is not changing? This one, right? It's pretty evident. That's why we'll add 0 on the left side here. Hello, am I clear?
Yes,
Yes,
sir.
sir.
Right. So you're adding 0 here, so that your 20 remains 20, doesn't become 200. Okay. So now this is my 21-bit data. This 21-bit data has to be stored in the format that has been given, where there are X. I need to replace those X's with my data. Okay, and then our work is done. Okay, so what I'll do is I'll select this much part and delete. Okay, so can somebody open that table and let me know what are the digits here? I guess these are 111 or 110. I'm not sure. These are 10, and then we have X. So I'll replace those X with dashes. And again 10, and we have X. And we have again 10, and we have X. Okay, I'm not sure about this bit. What this byte? What about here? Hello.
So, which row, sir? The last row or
The fourth bit. This one. The last row. You're not sure, still sure that why we are taking last row?
one? Yeah, 11110. Then X, X, and X.
Okay, okay. So there will be how many X's here? 5, I guess. Why? Because we need to make an 8-bit for a byte. This is 110, 5 X's. So this is 5. Okay, this is 6, this is 6, and this is 6. Is it? Are you sure about this one? This part?
Sir,
Hello?
that is 4, 1, and 1, 0.
Okay, 4, 1, and
Yes,
1.
sir.
That's what. Okay, just a minute. One, and 0.
One,
Okay.
one more 1 left.
Okay,
One,
one more one. Just a minute. So it's one more one. So 4 times 1 and 1 0.
Yeah.
Okay, right. Okay, so here we are having 3 bits. Here we are having 6 bits. Here we are having 6 bits, and here we are having 6 bits. So total 21. Right. So this 21 bits have to be stored here. Okay. Now we'll select 3 bytes here for here. So this is 0 0 1. So it is 0 0 1. Then we'll have to store 6 bytes. So it is 0 1 0 1 0 0. It is 0 1 0 1 0 0. Okay. Then we have this. It will be 0 0 1 1 1 0. And then we have last, so it will be 1 0 and 1 0 0 1. All right, so I have a 21, not 21 here. How many bits it will be? It will be 32. Okay, a 32 bit long binary number, right? I need to convert this 32 bit long binary number into a hexadecimal number. How do I do that? Hello.
Group 4.
Right, so we'll make group of 4. Yeah, so Mehak, are you there?
Yes, sir.
Yeah, so that's what. So you're getting right. You're having a 32-bit binary number. You want to convert it into hexadecimal. What will you do?
Divide by 10.
Divide by 10. Why do you want to divide by 10?
Sorry, 16. 16.
What do you divide by 16 actually?
First we take this binary. We can just multiply by 2 raised to power 6, 16 raised to power 0, 16 raised to power 1.
Yeah, but you will go till 16. So the last number here, it will be 1 into 16 to the power 31. Okay, so then you will get a number which is like very long, and then you will keep on dividing it by 16 again. Why? Like that is the right method, but it will take you eternity, right? So convert a binary, like a binary number into hex. What did I say at these? Just make groups, no? Just make groups of 4. Just consider the reverse process of this. If I am making a binary of each number, what am I doing? These are actually group of 4 only, right? Which represents each hexadecimal number. So similarly, this groups of 4 should single hexadecimal number. Is this clear?
I will make it easy. Show one like with 1 1 1 1, like the first part. Like,
Yeah, so this will be F. So 1 1 1 1 will be F. Okay, what will be 0 0 0 1?
1.
Yeah, it will be 1. Okay, next. What will be 1 0 0 1 0 0 1? So if you see from here, it will be 9. Okay, 0 1 0 0. Take the reference from here. It will be 4. 1 0 0 0. No reference. It will be 8. 1 1 1 0. So 1 1 1 0 is actually 8 plus 4 plus 2. That is 14. 14 stands for E. It will be E. Okay. 1 0 1 0. What did we have? 1 0 1 0? A. And what is 1 0 0 1? It's 9. Okay. So if I write all together, F 1 9 4 8 E A 9. This is the UTF-8 representation of this Unicode number. Hello?
yes, sir.
Getting?
Yes, sir.
Yeah, so this is how we do it. See, it's conversion of a hexadecimal number into binary. Okay, then put that binary into some predefined rule according to chart. and convert a different new obtained binary, the newly obtained binary, into again a hexadecimal. That is all we need to do. Okay, see, but for this to happen without any mistake, your conversion from decimal to binary, binary to decimal, and conversion from hex to binary and binary to hex should be good. So you need to, like, there should be practice on this thing.
Hello, sir.
Yeah.
I have a question that I don't know this is a perfect question to ask or not, but what are the things we are expected to, I mean, remember for the quizzes? Like in the other subjects, we have a handle kind of thing that we have to remember the formulas, the techniques, kind of things. But for this course, what are expected?
So this course, see, for you to like be good in the quiz, you need to do your lab assignments very carefully. Why? Because the concept, see, what we are doing here, we are not calculating anything, right? Yeah, apart, if you leave aside the questions that I've taken in the last Solve with Instructor session, that is the numericals, if you leave aside those questions, we are mostly coding here, right? Coding and come up with a web page. Okay, so things like HTML, CSS, how are things happening in HTML, CSS is what you need to understand. How generally things happen. Okay, you don't see, and there is no specific way of doing each thing, right? See, if I want to add a color, if I want to add a background color, there are no different ways. The ways will
Yeah.
be same only. So you need to get the skeleton, the actual way of how things are done, and then some properties here and there which you generally practice, right? So it's not that you need to remember anything. Okay, nobody will say that, okay, I'm learning CSS, but I don't know how to add a background color just because I don't want to remember it, right? So that is not expected. Some
No,
things are expected to
actually,
remember.
I am doing the assignments, and it is not a problem. And where I am getting stuck, I'm searching in the, I'm googling it and stuff like that. But that's why I am confusing that what are the things we have to remember.
Yeah, so things like, see, you need to remember, you need to focus on practice questions, is what I would say. Practice and graded questions are those level of questions that the questions, similar questions to those you will find in quiz. Okay, and wherever a practice question asks you to remember this, what is the syntax of this, leave it. Just it is just for your practice. That won't come in quiz.
Okay.
Right. So you need to focus on practice question,
But
graded
the
question.
but the how a syntax works, that we have to remember, right?
Yeah. So if something is written on the page, you should know, okay, this should do this. Right. So if you have gone through some of the coding questions of week 12, sorry, week 2, you may see that, okay, some codes are already given. What will be output is something that is expected from you. Nobody will ask you to, okay, make a website such that this is this. That will not happen, right? In a question.
Okay. How some code works.
Yeah. A certain codes, what will be the output? How will this browser render? How will that happen?
Yeah, got
Right.
it, sir.
So these questions, similar questions will be given in like similar question you may have seen in practice and graded. So that is what gives you an idea of how what kind of questions are asked. So now we are yet sure. See, we are only on week 2. So we'll add week 3 and week 4 also. There you will get more coding part, and the questions, as in what questions can come in quiz, will be more clear there.
Yeah. Okay.
So if you have not encountered any coding question, right? Okay, what will be the output? Just wait for week 3. Okay, so that is where we'll finally jump into coding part.
Yeah.
Okay.
Okay. So thank you.
All right. So I hope there is no question on this thing, right? Number system. If there is any confusion, just let me know. I'll try to clear it. Okay. So how good you're doing with the graded questions? Yeah, anyone wants to answer? Have you attempted graded questions? Hello. Okay, so, are you replying on? Are you raising hands or something?
So the graded questions have been attempted. Yes.
Okay. So things like the questions that are coming in graded is something you can expect. Like similar questions can be expected in quiz. Okay. So graded questions are those questions where you are not expected to remember anything, memorize anything, only based on concepts. Okay. And if at all we are asking you to, okay, what will be the syntax of this? This is something that you will have by the time quiz comes, you will have worked on it a lot. So there is no question of not remembering that or not knowing that. Okay, so yeah, and I guess week three content is available, right?
Yes, sir.
Yes,
Yes.
sir. Victory is now
Yes.
available.
Right. Okay, so you start solving since it is only Friday, Saturday, start solving so that we can have ample discussion on Wednesdays, right? So not be talking about for here. I'll not be talking about any week three question or concept. We'll do that on Wednesday. And then similar to that, we'll work on a solve with instructor session, which will be, adding up on what we did in the last two sessions. Not last two, last one, HTML, CSS, and then we'll add content of week three and do something with solve with instructor. And yes, this time I'll try to make sure that I start at 2 and finish at 4. Okay, is there anything else anyone wants to discuss? Any question? I'm open now.
So can you show like how to make rounded corners for heading? Like in the last session, we were doing that. So
Okay.
how to use the border property? Like,
All right, I can show that. Anyone up like should I carry on with the session what I left yesterday? So most of it I showed. I hope whatever I showed yesterday were clear.
yes, sir.
Okay, so no issues. I can do that. I'll just show you a simple border property. Like what are we doing with that? Just a minute. Okay, so I'll share this. Yeah, is this visible? Screen is visible. Replit.
Yes.
Okay, so for those who were not there in the yesterday's session, what we did was we tried to create a small HTML file, a static HTML page, and what we say, tried adding some stylings to it. Okay, so if I run and show you what we did last time. All right, so if I try to open this on the new tab, yeah, you can see this is a small page, a wiki page on data science. Okay, with what I've done is I've added certain headings. So these are different levels of headings. Okay, and then there are certain paragraph that is relevant to this data science part. Sorry for that, just a minute. Okay, then we have things like listing here, how lists are made in HTML and how the bullets of this list are given, that I've tried to show you. Then there is then how the links are added in HTML. Okay, so these are the links. And then if you can see that this is not the normal font that we see in creating in HTML document, this is a different font. And to be precise, it is Ubuntu. I've taken that Ubuntu font. Okay, how to embed font, how to come up with different fonts, that also I've shown in the last session. Okay, then there are other pages, like 2 pages attached to it. Okay, and this was the background that I tried to add. So this was like one of the queries, and I wanted to make sure if we can do that, but needs a lot, some more working on this is required. Okay, so the second page is like an additional page to that. So it's like a wiki page, right? So we also have additional information on a wiki page, which leads you to different parts. So here, if you observe this, the list is not numbered, it is bulleted. In the first page, we had a bulleted list, right? So here the links, if you see that this page will redirect me to the previous page. And then there is one more page called early usage. Okay, and the similar page, right? So what I've done is kept the styling and the look and feel of all the 3 pages same. The only thing is certain information is changed, images is changed. Okay, here again, if you see the terminologies here is it is an ordered list, but here it's not 1 2 3 4, it's A B C D. Okay, and then every page has links which can direct you to the other 2 pages. So if I go back to home page, yeah, so this is our page. Okay, so what I would so I also had shown yesterday a pre-built site which I did before, just to give you a reference. Okay, what that's the HTML page had was, it was having rounded corners here, and the same design, that background color from which is here in the heading, was there in the additional information also. Okay, but yesterday, due to lack of timing, we could not do that, and I asked you guys to just have a look at the border radius property. All right, so what I'll do is, since we have some 10-20 minutes, we'll try to do that. All right, so for this, again, we'll go back to inspect. So this is the developer tools, which lets you the information in each and everything, like what are the elements that you have created, how is the structure of your thing. All right, so this is the first part, right? The heading part, the div id container, which you can see here. If not, I'll just zoom in a bit. Why is this not happening? Because we are opening the developer tool. See, now it's zoomed in. Yeah, so we have this body, div, and main. So this is the thing. See, if I click on here and the elements here where I have the HTML file, the corresponding element on the display will get highlighted. See? So if I click here, see, this gets highlighted. Okay, now I want to target this and make a border radius to this, give a border radius to this. Okay, now this temporarily, just to see what changes I'm making and how it looks, can be done here. See, so if I'm selected an element, it will open a tab for me called element.style. Okay, so I can give all the changes here, see how things look, and permanent those changes by simply copying the text from here and adding into your original style. All right, so here I'll just add a border radius. Border radius. Okay, so if I start with 2 pixel, and if I increase this is a spelling mistake, right? This is not happening. So if you see that border radius is coming, right? So this is 10 pixel. See, I can simply click on the number and press my arrow key to toggle between the numbers. See, so if I click on increasing so if I keep on increasing the pixels, the radius increases, and thereby the borders become more blunt. All right, but this is happening on all the sides, right? So if this is your personal choice, if you want it on all the sides, this is okay. But if you don't want it on all the sides and just want to have it on only on the left and right, top left and right, what we can do is we can add certain parameters here. Parameters as in an additional part to that. It is border radius, but it is border top left radius. Okay. See, so if I write border top left radius, I'm getting radius only on one side. With this, what we can do is we can apply different border radius to every corner, right? Because what I'll do is I'll simply write border top right radius, similarly with bottom left and bottom right. So I can add different border radius on all the four corners that I have on the block. Okay, similarly what I'll do is copy this and do it for, see why, if I'm copying here, the upper one gets strike through. Why that happened? Because the second thing that you have written is the same property. That's why the second property is overwriting the first one. Okay, so whatever comes within the curly bracket are having order of precedence in the serial order. Whatever comes at the last will have the highest order of precedence. Okay, that will exist. So what I want to change now, it is top, but it is not left now, it is right. Okay, so if you see this, I'm getting blunt edges on both the sides, that too on the top. Okay, this is what I want. I need to permanent these changes, but if I don't copy it on my actual styling, okay, and if I simply close this and reload my page, see what happens. The styling that is given here goes away. Okay, but I want to make this styling permanent, so this needs to be added in your original styling document, right? Okay, so where did we make that change? It was in the first container, right? This was the container one with the ID container one. I need to copy it here. Just some alignment thing. Okay, so once this is done, I can simply reload my page and I'll have the borders rounded. Right? Now same styling, this is the same styling which I want for this part, which is the footer part. If I go to my index.html, this is the same styling that is happening to the this which is what I want in the footer. So this is actually the container 3 ID, right? This is container 3. So I'll go to styling. I'll go to styling and make the same changes for container 3. So I'm not writing anything in container class. It's container 3. But that is not a class, that is an ID. So to represent that it is an ID, we give a hash. Okay, and then all the things will be done accordingly. So this border property will not look good currently for this thing. Let's see how it comes. Okay, so if I try to reload this, let's see. Yeah, so I'll open in the larger page and we need to reload this. Yeah, so see how it is coming. This is not what I want, right? I want the blunt edges to come down. Okay, and then the information to shift up a bit. Okay, that is what I want to do. And the second thing is this relation to statistics and the links are not very easily visible, but they're looking good, right? Because the border has the same color. Okay, so what I'll do is I'll simply change this top to bottom. That is it. That is what I need to do. Okay, so this top needs to be done in the bottom. Okay, so if I reload this, yeah, this is what I wanted. But the thing is this relation is going out of it, right? And the border, the radius is looking a lot for this part. So what we can do is simply reduce its pixel. Now I'm not sure how much to reduce, right? So we can simply go to inspect, go to the last part of the page, target that particular ID and see these are the stylings that are already associated with this tag, right? So this all the stylings will come here. What I need to do is simply try and reduce and see this, right? So now this looks fine, 20, right? So what I'll do is rather than making changes here, I'll make these changes here, 20, 20. Okay, simply reload this. Yeah, so we got all the changes done, right? So we're having the same a website looking. Now, whatever changes that I've done here will happen to other pages also, right? So this is the thing. This will happen to other pages also. Why? Because I've linked the same style sheet to all the 3 pages, one thing. Secondly, I've kept the structure of all the 3 pages same. The structure as in the DOM structure. Now, what is DOM structure? The structure which shows this thing, right? Whatever is there, right? So document HTML. Within HTML, you have 2 tags, head and body. Within head, you have these many tags. Within body, you have these many tags. So this structure is called as DOM. Okay, so it is a tree-like structure. Okay, and this structure is same for all the 3 pages. That is why, and I have linked the same style sheet to all these pages. So if I make a change in one, if I make a change in one change in the style sheet, the change will be reflected in all the 3 pages, right? So this is what we have done, right? Is this clear? Any doubt in this?
No, sir.
Right. So this is what I wanted to finish with in the last session, but unfortunately, due to lack of time, we could not. Yes, Vinod, Vivek.
Sir, I missed the earlier session. I would just like to see how we are centering all the information in the page and specifying the width of our content.
Okay, so I guess it is something related to lab assignment. Okay, fine. But yeah, since I've shown it in the session, you should be able to see the session, right? If you miss this part in the session, in fact, was it your query in the discourse?
No, sir.
It wasn't. Okay, fine. No issues then. All right. So what you want is to know how these things come in center, right? Okay. So what happens is what we have done is we have kept the entire document in one div tag. Okay. Let me go to Replit only, where I can show you the preview as well as the code. Okay. So see, if you see here, the entire document, what follows the body, the div. This is the main div. I've ID'd it with main. Okay. And this div ends here. This is the end. So it ends with body, just before body. Okay. What will this div do? It will make the entire document a block document. Okay. The block statement, block element. Yeah, Ariman. So you pay attention here. I'm trying to show you, right? So here we have made everything as a block. So what the speciality of block element is, you can assign a width to it. Okay. So how did I assign a width to it? I'll go to style and show you this. See, this is main. All right. So since it is an ID, I'll target an ID using hash and then the ID name. See, if I put my cursor on it, it suggests me, okay, you are talking about element that is ID, whose ID is main. All right. Okay. So once the element becomes block, now what is a block element? Div, things like div, paragraph, okay, headings, these are all block elements. What are inline elements? Anchors, all right, links and images, span, these are all the inline tag. Okay, so I have given a very long discussion on what block and inline tags are. You need to watch this video, okay, which is there in the YouTube. Next is, so if now my width of the screen, if you see the width of my screen, it is actually 1880. Okay, it is 1880. So I need to assign a smaller width than that. Okay, a smaller width. So simply because I want my information to be compact and come in center. All right. So I gave a width. Once I gave a width, it will be something like this. So if I remove this for a minute, okay. If I remove this for a minute and you see this, yeah, everything goes in the left, but is having a width here. So boundary, the thing comes after this. If I had not given that width, if you see that if I had not given that width also, everything would have come and shifted to the entire screen. Okay, everything would have shifted to the entire screen. But this is not what I wanted. I want to leave some space on the left and right. That's why I reduced the width. Okay, how did I reduce the width? I gave a width to it. What we say, finite width. Let's say 800 pixels. Okay, once you set the width and you want to make everything in the center, there are 2 ways. One way is to Okay, so if I go on inspect, okay, and then I go to element.style, and if I go to margin left, okay, margin left, and start giving margin to it. Okay, so margin left will give only margin from the left side, not any other side. So if I do that, see, my content start shifting towards right. Okay, so my content starts shifting towards right. And you keep doing this, and finally you will reach to a place where this looks like the center of the page. All right, this is well and good. This will work. This will suffice whatever your requirement is. Bring the content towards center. No issues. But what happens if I change my screen? Okay, if I change my screen, let's say if I change my screen to this. Okay, this is the screen. Can you see this? So my entire data shifted towards right. Why did that happen? Because I have fixed my margin to 524 pixel. The 524 pixel margin, let me go back to my original part. Yeah, just a minute. Now, where is that original? Just a minute. Yeah, this one. It's not coming for now. It was 1880, right? Let me go there. Yeah. Okay, I'm not getting how to get it to the center. All right, but the thing is, it happened. Okay, doesn't matter. It is just for the responsiveness. But what is happening here? This margin is not. This is set as 524 pixel towards the left. Okay, but it doesn't matter. It doesn't take into consideration about the screen. It is not actually making the entire content to the center. Okay, this is just giving a margin so that your information looks as if it is in the center. Okay, so what I have done to remove that is to actually make it center for irrespective of the screen size. What we do is we do this thing, that is margin auto. We set the margin to auto. What it does is it will set it automatically in the center irrespective of the screen size. All right. So if I reload this and reload this too, see, doesn't matter what screen size it is, it will be in the center. Okay. So this is how you make things in the center. So you need to make the thing, entire content of it, you should make it such that it is a block element, assign a width to it, and make the margin auto. So doesn't matter if you're increasing the width to 1000 also, but it will remain in center. Yeah, so width increase, but it remains in center. Is this clear?
Sir, I had a doubt regarding the width of the content that you have created. It's 800 pixel, right?
Yeah.
Sir, if we have a different screen size, for example, if this is the website that we're opening in the computer, and if the same website is being opened in a mobile phone, then the width would differ. And the screen size of mobile phone is quite smaller as compared to the one in computer. So if we take away the width factor and let the margin be auto, then all the content will be in the center, and from one is to the other, the content will align itself, right?
Yes.
But if we want this type of content, that is the width is equal to 800 pixel in the computer screen and not to exceed, then how can we actually manage that? I didn't get that.
Not to exceed 800 pixel.
Yes.
Right. So see, you want it should not exceed 800, right? So the maximum width should be 800, right? Just write max width. Done.
Okay.
Right. So it will be 1000 here. Okay. I'll show you with a smaller size. Let's say if my width is, let's say 500 pixel. Okay. So if I run this, it will shrink a bit. No doubt, no issues with that. Okay. Forget about this image for now. So if you go to inspect, okay, and then this is where you see if your device is actually being responsive or not. Okay. So this is where you change the screen size and see. All right. So see, it remains in center. Okay. I'll close, I'll keep this. Okay. So it remains in center, See, it remains in center, but now the width reduces. See, width reduces, right? It has become 300.
Yes.
Now, if I keep on increase, it will increase, but it will stop when the width becomes 500.
Exactly. Yeah, that is what I was thinking.
Right. So you just have to keep the attribute to max width. That's it.
All right.
Sir, is there a min width also?
No. Why is there not a min width? Yeah, actually there can be. Hello. Has anybody unmuted themselves? Hello.
No, sir. Continue.
Yeah. So the thing is, min width is a bit confusing. Why? Because see, if this is the screen size, right? If I'm reducing the screen size, if you're saying that if you keep a min width of let's say again 400 pixel, what will happen? It will not shrink, but it will go to there will be a slider like this in the horizontal axis. Let's try that. So I'm setting a max width of 800 pixel because I don't want my image to spoil. Okay, then I'm setting a min width. See, it is showing min width, right? So if I put a min width of 400 pixel, so if I set a min width of 400 pixel and reload it, what will happen? See, it has set. Let me reload this. Yeah, so it has set itself to 800 pixel, that is max width. Cannot go beyond that. But if I go smaller than that, 400 pixel, see you are getting horizontal scroll.
Yes, sir.
Right, so that is happening for the image. See, my data has got cut. Right. So this is what will happen.
But so why is it in center?
Sorry.
Why is it like not in center? Like it's going on the left every time.
That is due to see, because you are keeping the entire document in center. What happens below 400 pixel is your image is in the center.
If this image wasn't there, then this would have been in center.
Yeah, then this would have been in center.
So why isn't image like like becoming small?
See, because image has its own size. It won't shrink unless you give it a size. All right. So here if we see image, right? So we are giving it 800 width and 390 pixel. So it will not reduce below that. So image size is setting the image to that pixel. It is not actually the size of content or the block or that element. Elements will adjust by themselves, but image will not. Okay, because as that's what I said, right? So image will reduce in height and width, but it will not shrink or expand, right? So it will reduce in height and width, but it will not shrink or expand.
How do we adjust it according to different type of screen sizes?
Sorry?
Then how do we adjust the image according to different screen sizes? So what if we want a smaller size for phone, bigger for iPad? Like how can we make it adjust?
Yeah, so there are things like Flexbox. Right, so there are things like, so these are more more detailed concepts of CSS. When you go into detail, there are things like Flexbox. And Flexbox is like, if you use Flexbox, you don't need to worry about this display block and this and all this. So these are all modifications of CSS, right? So the problems that you're facing now, that how do I change the image to according to my size, then there is certain development on that, so that we come up with a Flexbox. So I would suggest you go through the content of Flexbox. Okay, Flexbox will allow you to shrink the image also. Okay. Yeah, so whatever I'm telling you is basic CSS that you might need for the entire course. Okay, so if you want more complex CSS to embed in rather than writing it, just use Bootstrap, right? But if you're still interested in, no, I should know and my design should be my design, then there are major concepts like X width, Y width, max width, right? Then there are, so see here, what is the unit that we have used? Only pixel, right? But see, if I delete this pixel and write only E, see, these are other units that I'm getting, right? If I write %, these are other units. So there are other units. So these are all are the units that can be used. So this is how you change things. But what we are using pixel because it is most obvious one, a most intuitive one. Okay, 5 pixel means 5 pixel. So if I talk about EM is actually the multiple as in, by default, if your font size is having 12 pixel size, if you put it as 2 EM, your font size will become 24. It's like multiple. So all those things are used in some or the other way to make your site the way you want. Is that clear?
Can you explain EM again, sir?
See, okay, so let me go to something called so EM has something to do with font, right? So we'll go to paragraph. Yeah, this paragraph, right? So what I'll write is font size. See, if I give font size, these are the units that you can put. Okay, then this is EM. Okay, so initially, if I put 12 pixel as my font size and reload this, okay, so this font has come in 12 pixel. Okay, if I want to double this font size as it double from what I had previously, what the original default, right? So original default, what it was. So we don't know that number, right? So if you don't even know the number, right? That is the issue. If I don't know the number, what was the font size I had before, and I want to exactly double, what do I do? I simply write font size and set it to 2 EM. Okay, doing that will double the font size. See, so it will become double the original one. So you don't have to worry about what was the original. What? So these are various. Yeah, so these are various things we need. So EM and things we will use for images. So I want this image to be double the original image, things like that. Okay, then there is percentage. I want this screen size to be this much percentage, right? Then there is things like H fix. I'm not actually recalling the units because that's what. Why am I not recalling? Because we generally don't use that. So it's EM. Then there is REM. REM has something that is related to its parent element, things like that. So there are so many details. Then see there you have centimeters, inches, pixel, things like that. So there's so many things. Yeah, this is what I said.
If you use percentage, what will it consider as the base value?
The parent element. See,
yes,
so you see this div, no? This div is having this div. This main div is the parent of everything, right? Let's say. So this max width is 800. So we have set the max width to 800. So if I set 550%, so its width will be 400 pixels, things like that. So these are all just things which you go and play around. Okay. Okay, what is the default unit? Like if we use border 1, then here 1 is in pixel or something else. It's in pixel. Generally, we talk about in pixel. It's in pixel, and then there is one relation, as in I guess 72 pixel would make up 1 inch. Okay, so generally it is in pixel because screen sizes are calculated in pixel. So it would be a better, most intuitive way of finding out, okay, what size you want and with respect to what size the screen is. I think if you don't give anything, I'm not sure if it does anything. Border. Yeah, so it has removed that. So it doesn't understand, right, what this means. So you need to write pixel. So by default, you need to write pixel. If you don't write anything, it wouldn't understand what it is. So a single number without unit will not mean anything. Okay, so just let me see this if it's fine. Yeah. This EM, I don't want this, right? So we can simply hash it. Right, so is this part clear then? So this is what I wanted to give an idea about in the CSS and HTML. Sorry. Yeah. All right. So yeah, this is it, right? Anything else?
Sir, I have a doubt. Sir, CSS seems to be very vast and extensive. So, what all are we expected to remember? One, from the point of view of this course, and two, from the point of view of basic application design. Is there like a reference of what all we need to remember?
Yeah. So the thing is, whatever I've told you till now is something that you need to remember. One thing. Secondly, what things that you need to remember will be cleared from this and coming week 2 and week 3. Okay. So the questions that are from practice and graded will be a pointer as to, okay, so if there is something called as there's something called as inheritance, that is something called as precedence of CSS, things like that you need to remember. And basic things like font size, background color, how colors are assigned apart from what it suggests, right? So it is suggesting me some colors, but I don't want those. I want to put it in RGB. What are other ways of putting colors into only RGB, or we can put a hex code or things like that. Okay, so basic CSS is what you need to know. Apart from this, we are working on a wiki that will give you an idea, I guess. Yeah, so we have started working on HTML also, so there will give you a pointer on these are the things that you need to remember in HTML. Similarly, that will be done for CSS and all the coming weeks.
Okay, sir, thank you.
Okay, so this will be out to you before quiz, so don't worry about that. Apart from that, if you find anything there is in the question that you don't get or wasn't taught, discourse is the way, right? Put it on the discourse and we'll try to play.
Sir, will we have any mock test for this subject?
Yeah. So before every quiz, will be a mock test will be given. Wiki is like something. See, Wikipedia. I've taken wiki. The name or this reference is given. See, if you search something on the net, first thing that appears is Wikipedia, right? So it is having vast information in terms of static pages, right? So that is what we are trying to do. There is nothing dynamic or there is nothing website that you want to give you. We want to give you a static build where certain information is there. Okay, so you can consider it to be a very little friend of MDN Talks, right? So there all the tags and information is given in very much detail, everything that is there. So we won't do that. We'll target only those things that are relevant to our course. Yes, I'm talking about the reference material, Nitish. Okay. Yeah, so about mock, yeah, before the paper you will have a mock.
Thank you, sir.
That will give you an idea of how questions are, what type of questions are created or asked you in the quiz. Okay, is that it? Yeah, so still there is any doubt, you can ask me. I'll wait for 2 minutes, 1 minute, not more than 2 minutes. And then other than that, if there is anything related to or specific to questions, you can ask on Discord. Right? Do you all have any other session now at 1?
Yeah,
Yes.
we'll have to prepare for MLF now.
Okay. So if you have any session now, you can leave the session. And I guess we are pretty much done. So if there is any doubt, we'll talk. Otherwise, we can call it a day for AppDev1.
Okay, sure.
Okay then. Thanks for joining.
That's all.
Thank you.